Hello, we here discuss next last part of that applied electrochemistry, which include in that electrochemistry unit, that is Taffel's theory of hydrogen over voltage. Taffel's theory of hydrogen over voltage. We already explained what is meaning of over voltage and why we observe over voltage. That is, over voltage is nothing but it is difference between actually required potential for discharge of gases or metal atoms on the respective electrodes and theoretically calculated discharge potential, that is decomposition potential for evolution of gases or deposition of metal ions. We already seen that for deposition of metals on respective electrode surfaces, that deposition over voltage magnitude of over voltage is negligible, while for evolution of gases on the metal surfaces, that magnitude of over voltage is considerable. And Tafels explained why that evolution of gases results in over voltage. That is, why for evolution of gases like hydrogen gas at cathode that require more voltage than theoretically calculated voltage for evolution of H2 gas. Why that H2 evolution results in over voltage. The Tafels gave different stages for evolution of any gas at respective electrode. For example, for H2 evolution at cathode, there are different steps, as like first step is migration of that H plus ions from solution towards cathode surface. That ions, H plus ions, start to migrate towards metal surface, cathode surface. This is first step. Second step is that H plus reached at the cathode surface, and on reaching there they accept electron at cathode surface and convert to H atoms. Third step is that different H atoms combine, that H atom generated combine with adjacent H atom, and there is formation of H2 molecule. Then last step is, fourth step is, many H2 molecules combine to form H2 bubble, gas bubble. These are several intermediate steps involved for any gas like H2 evolution at cathode. If all these four steps takes place smoothly, no any difficulty is there for any of above steps, then there will be no over voltage. But actually, one of the step from these four steps, one of the step becomes difficult. That step is slow step, which results in development of overvoltage. Tafel explained that out of above 4 steps, third step, that is that H atom combine with adjacent H atom and there is formation of H2 molecule on the surface of cathode, metal cathode. This step is difficult and therefore that evolution of gases results in development of overvoltage. Based on this, Tafels gave a general equation showing the relationship between overvoltage and current density. That general equation is that eta is equal to A plus B into log of I. Eta is equal to A plus B into log of I, where eta is where overvoltage, magnitude of overvoltage, I is current density, and A and B are constant values which depends on nature of cathode surface. Then A depends on nature of cathode surface and value of B, constant B, depends on other conditions, experimental conditions. That this is important equation, that is eta is equal to overvoltage is equal to A plus B into log of I. This equation is known as Tafel's equation. And as the Tafels used different metals as a cathode, and he also calculate overvoltage for different metals for evolution of H2 gas. And it is observed that if by using catalysts, catalytic surfaces, that magnitude of overvoltage can be decreases by increasing the rate of that difficult step, that is H atom combined to form H2 gas. That one is difficult step. That speed of that step can be increased by using catalytic metal surfaces as a cathode. Then that value of that overvoltages depends on different factors. Following are the important factors which affects on value of overvoltage. First factor is current density. That hydrogen overvoltage, that is not removed by that hydrogen is not removed by reaction with oxygen or any other oxidizing agents. The overvoltage can be increases with increasing the current density. That one is directly proportional. Overvoltage is directly proportional to current density. As current density increases, overvoltage can be increases. Then second factor is pH of the solution. In strong acidic or strong alkaline solutions, deviation occurs due to large concentration of H plus and OH minus ions near the electrode. And next factor is temperature. That is pH of the solution also affects. That is more the concentration of H plus and OH minus ions, then there may be, because of there are difficulties for that 4 steps increases because of increase in H plus and OH minus ion concentrations, and that can be increases magnitude of ore voltage. Then next is temperature factor. That ore voltage is due to slow movement ionic discharge process. It and ore voltage decreases with increase in temperature. That is inversely related. Ore voltage is inversely proportional to temperature. That is, ore voltage decreases as temperature increases. Then impurity, that ore voltage magnitude is largely depends on impurities of that cathode material. As impurities increases, impurities content increases, ore voltage also increases. And last factor is pressure. It has been observed that at higher pressures, ore voltage is slightly affected, but at low pressure it increases rapidly on cathodes of copper, nickel, etc. That is, at low pressure, ore voltage increases. At high pressure, no effect on, or there is small effect on ore voltage. These are different factors which affects on that magnitude of ore voltage. And we also discussed that Taffel's theory or Taffel's equation for ore voltage, hydrogen ore voltage. Thank you. Based on this ore voltage and that equation, ore voltage equation and Taffel's equation, there are some examples which are given in your book also. Small examples for 2 to 3 marks. You try to solve that examples, and that one is a part of application of that ore voltage concept to that for electrochemical cells. Thank you. We stop here.